Hi, hello, and welcome back. Guys, in this video, we are going to see how to balance chemical equations. This topic is so important in your 10th class, 11th class, 12th class. Whenever you see chemistry, if you want to learn concepts in chemistry like chemical reactions and equations, acid, bases, and salts, or metals and non-metals, you will get a lot of chemical equations. And if you learn chemical equations, it will be so helpful and easy for you to understand concepts. So in this video, we will see how to balance chemical equations, and to learn that we need few concepts. So if you want to understand how to balance, you need to understand first counting number of atoms, that is important. Basically, what is chemical equation, you need to understand. And last one, what is meant by law of conservation of mass. If you understand these three, then it will be so helpful for you to understand how to balance chemical equations. So first we'll see chemical equation. Chemical equation is nothing but representing chemicals, formulas, symbols, and if you make it as an equation, in simple equation, that is chemical equation. In chemical equations, you can find symbols, you can find formulas, sometimes you can find its states. So symbols like sodium, oxygen, hydrogen, etc. Formulas like S2SO4 means sulfuric acid, H2O water, NaCl sodium chloride, etc. States like liquid state, gaseous state, solid state, aqueous, etc. Now, first form of chemical equation is word equation. What is meant by word equation? Word equation is nothing but if you represent an equation with the help of words. For example, hydrogen combines with oxygen to form water. Here we are not using any symbols, we are not using any formula, etc. Just we are using words, and this word equation can be converted to symbolic representation. Symbolic representation. This symbolic representation is known as chemical equation. And all chemical equations should be balanced. All chemical equations should be balanced. If you didn't balance, that chemical equation is known as skeletal equation. Now let us write this hydrogen. Hydrogen means we'll write H2, oxygen O2 gives rise to water H2O. What we have learned? Every chemical equation should be balanced. Now what is meant by balance, or what is meant by balancing? Balancing is nothing but every chemical equation should satisfy law of conservation of mass. What is law of conservation of mass? Law of conservation of mass states that the same number of atoms should be present on both sides of the chemical equation. So try to understand that sentence. Law of conservation of mass states that same number of atoms should be present on both sides of the chemical equation, and if there is same number of atoms, then we can call that equation satisfied law of conservation of mass, and any equation, if it is satisfying law of conservation of mass, then that equation is balanced. For example, we will see this. H2 plus O2 gives rise to H2O. Now, how many hydrogens are there? 2 plus how many oxygens are there? 2. 2 plus 2, 4. Here, how many hydrogens? 2 belongs to hydrogen, so 2 plus how many oxygens? No number here, no number here, hence it is 1. 2 plus 1, that is equal to 3. So 4 not equal to 3, isn't it? LHS and RHS count should be same. That's what here we are talking about. It states that number of atoms should be present on both sides of the chemical equation, same number. Now, once again, if you observe here, what we are going to learn in this video, counting number of atoms, we'll learn what is chemical equation. So chemical equation is a symbolic representation of symbols, formulas and states. And while coming to chemical equation has two parts. Chemical equation has two parts. First part is before reaction part. Second part is after reaction part. Before reaction part, we need to call it as reactant side. After reaction, we have to call it as product side. In between reactant product, there will be one arrow mark. We have to pronounce this one as gives rise to. Gives rise to what? New product. Now, if you see that previous equation, this one, reactant side, hydrogen, that is H2 plus O2. Hydrogen and oxygen both are reacting together with each other, so that it is known as reactant side, gives rise to, we are getting new product by the combination of hydrogen and oxygen, that is water, that is product side. Now hydrogen and oxygen known as reactants. H2O is known as product. Guys, if you have any other thing, plus if you have something, we can go with plural form like products. That is. Now, you have some idea. Now, chemical equation, there will be two parts, before reaction part, after reaction part. Before reaction part, we have to call it as reactant side, and after reaction, we have to call it as product side. Now, if you observe this example, hydrogen, oxygen, both are reactants. H2O is product. Now, all chemical equation should be balanced. Balanced means it should satisfy law of conservation of mass. Try to understand this flow chart. Whenever you take chemical equation, that chemical equation should be balanced. What is the meaning of balanced one? I mean, if it is balanced, we will call it as balanced chemical equation. Balanced chemical equation. That balanced chemical equation means equation which is satisfying law of conservation of mass. What is meant by law of conservation of mass? Reactant side and product side, number of atoms should be, so reactant side atoms, product side atoms, count should be same. Count must be same. Now, we need to learn how to count number of atoms. That is the main trick to balance the chemical equation. Let us jump into the topic that now. How to count number of atoms, that is the main topic. To count number of atoms, I'll go with 6 to 7 varieties. So if you understand each variety, that would be helpful for you to count. So we'll go with first variety. When you have any atom, single atom, for example H stands for hydrogen, O oxygen, C carbon, N nitrogen, Fe iron, something like that, few examples. If you find any atom and if you don't have any number here or here, that place is known as subscript. If you remember mathematics, you will write x square or x cube. These 2, 3 places known as superscript, and down if you represent it is known as subscript. From now onwards, if I say subscript, please remember this place. We don't have any work with this superscript. Now, we don't have any number in front of the hydrogen. We don't have any number at subscript. So if no numbers are present, its actual number is 1. How many hydrogens are there? 1. If you observe this oxygen, no number here, no number at subscript. So how many oxygens, if I ask you, you have to say only 1 oxygen we have. Now while coming to this carbon, how many carbons? 1. Nitrogen, 1. Iron, 1. If you find a number in front of the element, for example, if you have 3, or if you have 2, or if you have 6, now this 3 will be counted for this carbon, 2 should be given for this nitrogen, 6 should be given to this iron. Now if anyone asks you how many carbons are there, you have to say there are 3 carbons, there are 2 nitrogens, there are 6 irons. So what is the first variety? If you find any number in front of the atom, that total count should be given to that particular atom. Moving to second variety. In this second variety, if you have elements, example Al, aluminium, Mg stands for magnesium, Si stands for silicon, Cl stands for chlorine. Okay, let us take these 4. Now if you have any number at subscript, for example Al2, Mg4, Si6, Cl3, something like this. Now this count also should be given to these atoms. Now if they ask you how many aluminiums are there, you have to say there are 2 aluminiums, there are 4 magnesiums, how many silicons? 6 silicons, how many chlorines? 3 chlorines. So if any number is in front of the atom, total count should be given to that. If any number is at subscript, total number count should be given to that. 2 varieties done. Let us see third variety. If you have an element, for example oxygen, aluminium, iron, sodium, magnesium, etc. If you have numbers at front at the same time subscript, for example 2O2, guys be careful when you are writing a number, when you are representing a number in front of the atom, that size should be equal to the atom. And while representing a number at subscript, that should be small. So 3Al4, 6Fe3, 4Na5, 8Mg2. Now, if they ask you to count number of atoms, what to do? You need to multiply these two numbers. So first we have to subscript, you need to multiply 2 2s 4. How many oxygens are there? 4 oxygens. How many aluminiums? 3 into 4, 3 fours, 12. Now, how many irons? Yes, you are correct. 6 into 3, 18. Now, how many sodiums? 4 into 5, 20. How many magnesiums? 8 twos, 16. Yeah, like that you need to count. So if any number is in front, total count should be given. If any number is at subscript, total number count should be given. If a number is at front at the same time subscript, you need to multiply those two numbers. So we are done with 3 varieties. Let's go with 4th variety. Till now we have seen elements and atoms. Now we need to go with molecules or compounds. Now we have few molecules like NaCl stands for sodium chloride, HCl hydrochloric acid, KOH potassium hydroxide, NaOH sodium hydroxide. Now consider these all are molecules. Now in this molecule, first molecule we have sodium and chlorine. In second we have hydrogen and chlorine. Guys, that molecule will be one, but while you are counting atoms, you have to separate everything. Now if you observe this third, KOH, we have K stands for potassium, O stands for oxygen, H stands for hydrogen, and last NaOH, 3 we have. Now if any number is placed in front, 2 NaCl, 3 HCl, 4 KOH, 5 NaOH, then this 2 count is given to sodium. At the same time 2 should be given to chlorine. So how many sodiums are there? 2. How many chlorines are there? 2. Now 3 should be given to hydrogen, 3 should be given to chlorine. So now number of hydrogens 3, number of chlorines 3. Now while coming to here, 4 should be given to potassium, 4 should be given to oxygen, at the same time 4 should be given to hydrogen. So how many potassiums? 4. How many oxygens? 4. How many hydrogens? 4. Now can you tell for this? Yes, it is quite easy for you to count. Sodiums 5, oxygens 5, hydrogens 5. That's it. Moving to next variety, 5th. Here we are taking molecules like this: H2SO4, FeCl2, C6H12O6, H2O, etc. Now, which number is given to which atom? Whenever numbers are at subscript, guys, we should not change this, because these are valency numbers which are given to that one, and we are not supposed to change these numbers. 2 should not be written as 3, 4 should be written as 8. Now, this 2 is after this hydrogen, so 2 should be given to hydrogen. For S, we don't have any number. This 4 should be given to only oxygen, not for sulfur. Please remember. And for ferrum, iron, we don't have any number here. And this 2 should be given only for the chlorine, not for iron. 6 number is given to carbon. 12 number should be given to only hydrogen. this 6 number should be given to oxygen, and here 2 should be given only for the hydrogen, not for oxygen, and for oxygen we don't have any number. Now if they ask you how many hydrogens in first, 2. Sulfur, here we don't have any number, here we don't have any number, here we don't have any number. So 1. Oxygens 4. How many irons? 1. Chlorines 2. How many carbons? 6. Hydrogens 12. Oxygen 6. Hydrogens 2. Oxygen 1. Like this you need to count. So that number which is present at subscript should be given to the only front atom. That is 5th variety. Moving to 6th variety. Same, let us take this H2SO4, FeCl2, C6H12O6, H2O. Guys, now if you represent a number, for example 3, 4, 2, something 5, etc. Now which number is given to which atom? As we discussed in example 4, variety 4, if a number is placed in front of molecule or atom or compound, that number should be given to all the atoms present inside this. So while coming to here, 3 should be given to hydrogen, 3 should be given to sulfur, 3 should be given to oxygen. Second, 4 should be given to iron, 4 should be given to chlorine. Here 2 should be given to carbon, 2 should be given to hydrogen, and 2 should be given to oxygen. 5 is given to hydrogen, 5 is given to oxygen. Now 2 should be given to only hydrogen. For sulfur, no. For oxygen, 4 is given. Nothing is given for iron, 2 for chlorine. In third example, 6 for carbon, 12 for hydrogen, 6 for oxygen. In this fourth example, 2 for hydrogen, nothing for oxygen. Now, if they ask you to count hydrogen, front 3, subscript 2, what we need to do? You need to multiply 3 into 2, 6. For sulfur, only 3 is distributed. 3 for oxygen, 3 from front, 4 from subscript, 3 fours. Yes, it is 12. Iron, only 4 is given, 4. Chlorine, 4 is given, 2 is given, 4 twos, 8. Carbon, 2 from front, 6 from subscript, 2 into 6, 12. You can tell for hydrogen, 2 into 12, 24. For oxygen, 2 into 6, it's 12. And for hydrogen, 5 to 10. For oxygen, it is 5. You need to multiply and distribute all these numbers. And seventh variety. Now we are taking special type of compounds. Here you can find compounds like Fe and with one bracket, OH, bracket is closed. At subscript we have to Al2 brackets, SO4 bracket closed 3. We have another example, Pb NO3 after brackets 4. Now how to pronounce this? You should not say FeOH2 Al2 SO4 3 Pb NO3 4. No. Whenever you find brackets, you have to pronounce like taken. Taken. Now, if you have 2, you have to say twice. If you have 3, you should say thrice. If you have 4, 5, 6, 7 and so on, you have to say 4 times. If it is 5, we have to say 5 times. If it is 6, we have to say 6 times, etc. Now, you observe this, how to say FeOH taken twice. You have to give small gap, at least 0.5 seconds gap while you are pronouncing it. FeOH taken twice. If you say FeOH taken twice, it seems to be like this. FeOH taken twice. No. FeOH taken twice. Al2, SO4 taken thrice. Pb, NO3 taken 4 times. So if you have 6, Pb, NO3 taken 5 times. Like that you have to pronounce this. Now which number is given to which number? Here 2 is there. That 2 should be given to brackets, I mean for oxygen and hydrogen. Here 2 is given to aluminum. In SO4, 4 should be given only for the oxygen, isn't it? Next, while coming to this 3 is applicable for atoms which are present in the brackets. What atoms are there? S and O. 3 should be given to sulfur. At the same time, 3 should be given to oxygen. Now here, Pb, no number. NO3, in that 3 should be given to oxygen only, not for nitrogen. Now 4, this number is applicable for the atoms which are present in the brackets. So 4 is given to nitrogen, 4 is given to oxygen. Now if you count how many irons? 1 iron. How many oxygens? For oxygen only 2 is given. 2 oxygens. For hydrogen, of course, 2 is given. Like that. Next, how many aluminiums? 2. How many sulfurs? 3 is only given to sulfur. No number here, no number here. So 3. Now while coming to oxygen, 4 is given, 3 is also given. 4 3s, 12. For PbNO3 taken 4 times. How many Pb? Lead, 1. How many nitrogens? 4 is given to nitrogen. So 4. While coming to oxygen, 3 is given, 4 is also given. 4 3s, 12. Like that. And at last, 8th variety, last and final variety. After that, we'll see how to balance equations. So we have, let us take Pb, OH taken twice. We have Al2, SO4 taken thrice. Now I think so you are familiar that which number should be given to which atom. Now if I place numbers like this, 3, 3. Now if you say Pb, how many Pbs? 3 should be given to Pb, right? 3. How many oxygens? This 3 which is present in front should be given to oxygen. At the same time that should be given to hydrogen. And this 2 should be given only for the hydrogen. Now how many oxygens? Of course 3. How many hydrogens? 3 is given. You can observe one arrow mark here. 3 is given. You can observe another arrow mark here. 2 is given. 3 into 2, 3 to 6. Now how many aluminiums here? 3 should be given to aluminium. 2 is given to aluminium. 3 into 2, 6. How many sulfurs? 3 should be given to sulfur. This 3 should be given to sulfur. 3 into 3, 9. And how many oxygens? 3 should be given to oxygen. This 4 should be given to oxygen. This 3 also should be given to oxygen. So 3 into, which is present here, 3 into this 4 into this 3. 4 3s 12 into 3, 12 3s 36 oxygens. Like that you need to count number of atoms. 6 varieties. First, if any number is given in front, total count should be given. Number 2, if a number is at subscript, total count should be given. Number 3, if a number is at subscript and superscript, both numbers should be multiplied. Number 4, if any number is placed in front of the molecule, total count should be given to every atom inside the molecule. Number 5, if you take any compound, of course molecule also, if any number is present at the subscript, that number is alone given to the atom which is present in front of the number. Number 6, if a number is present in front of the molecule or compound, and if you have subscript, both numbers should be given, but front number should be given to all the atoms and subscript should be given to the particular atom. Number 7, if we have compounds like hydroxide, sulfates, nitrates, in brackets that number should be given distributed to all the atoms which are present only inside the bracket but not for the outside atom. And if you place any number in front of the compound, then total count should be distributed. Now you are familiar with the counting number of atoms. If you know counting number of atoms, 90% of the balancing chemical equation concept is done. Remaining 10%, the 10% is nothing but adding numbers. Adding numbers. 90% is counting numbers. Now you are very much familiar regarding counting numbers. Now we'll see the 10% by taking few examples. Okay guys, here we'll take few examples such that it will be easy for you to understand the concept. Now these are chemical equations which are not balanced, few are already balanced. We'll see how to balance this. So to balance, first we'll see trial and error method. After that, we'll try to balance equation without writing anything. So first for few equations, let us try to write it. So first what we have to do, you have to mention here, try to mention reactant side, and here let us mention product side. Now let us take first equation, this one. We have N2 plus H2 gives rise to NH3, they told. So try to write number of atoms and what are the atoms are present reactant side. What atoms we have? Nitrogen, hydrogen. So reactant side means before this equation. Product side means after this equation. After equation products, what are there? Again, what you have to do, you have to take individual atoms now. Now in NH3, what atoms are there? Nitrogen atoms, hydrogen. So simply to say, what are the atoms you have written at reactant side, same thing will be repeated at product side, simple. Now try to count. How many nitrogens reactant side? So when any number is given at subscript, total should be given to that. So 2, and hydrogen subscript we have 2, and product before nitrogen and at the subscript we don't have any number, so 1, and for hydrogen we have 3. Now 2 here 1, 2 here 3. Both are not equal, so it is not satisfying law of conservation of mass. Then what we have to do? Let us go with trial and error method. What is trial and error method? Place one number in front of the atom. If it is not satisfied, erase that, go with new number. That is known as trial and error. Now here we have nitrogens 1, hydrogens 3. What we can do here, if you observe hydrogen 2, isn't it? This is even number, this is odd number. Now if you multiply with a number, both answer should be same. Here what we can do, 2 can be multiplied with 3, 3 can be multiplied with 2, such that it will become 6, here it will become 6. So what we can do, in front of the hydrogen, here one thing you have to remember, you should never touch this subscript, as I told you. Never add any number at subscript. Only you have to add number in front of the atom or molecule or compound. Please remember. So hydrogens 3 we have here 2. So if you add number 3, it will become 6. And if we add number 2, now 2 is given to hydrogen, right? How many hydrogens now? 3 has become 6. Here this side, reactant side, 2 has become 6. Now 6, 6 equal, but if you place 2 here, 2 is given to nitrogen also. But here if you observe, how many nitrogens? 2 we have. So 1 has become 2. If you observe 2 and 2 reactant and product side, 6 and 6 reactant and product side, both are same. Now if you count 2 plus 6, it is 8, and 2 plus 6, now it is 8. Now we can call this one as balanced chemical equation. So this equation here, blank is there, what to represent? Don't represent 0. If you want, you can represent 1, or just you can leave it. Like that you need to balance. Now let us take this second, just I'll rub this such that you can. Okay, if you observe that second equation, you can write in your notes if you want to balance it. So reactant side, here we have product side. Reactant side, second equation, what atoms are there? K, Cl, O. We have K, Cl, O. Product side, no need to search, same thing you can write. K, Cl, O. If you want, you can recheck it. K, Cl, O. Okay, reactant side, how many Ks? No number in front. 1. How many chlorines? 1. How many oxygens? That 3 should be given to only for oxygen, isn't it? 3. Product side, how many chlorines? 1. How many potassiums? 1. Chlorines 1. Oxygen 2. Now, how to balance this? I told here 3 is there, here 2 is there, 1 is even, 1 is odd. So if you multiply with a number, that answer should be same. Simple. Here you can substitute 3 to make it 6. Here you can substitute 2 to make it 6. Now if you place 3 in front of oxygen, product side, oxygen has become 6. Reactant side, if you place 2, oxygen become 6. But there is a problem. While you are placing 2, that 2 should be given to potassium, chlorine and oxygen as well as. Now oxygen is okay. How many chlorines we got? Now reactant side 2 it has become, product side 2. Here if you observe, product side, of course reactant side, it has become 2 and 2. Product side, what we have to do? We have to place 2 such that 2 can be given to chlorine, 2 can be given to potassium. I mean this potassium and chlorine. Now this one becomes 2, this one becomes 2. Now if you see 2, 2, 2 chlorines, 2 chlorines, 6 oxygens, 6 oxygens, done. Like that you need to balance. Let us take this third example also. Just for few equations we are writing reactants and products, but after that directly you can see the equation to balance it. Now reactant side, what we have? Third equation, we have sodium, chlorine plus F2, F fluorine. Now product side, same thing you can repeat, NaCl, F. Now try to count. Reactant side, how many NAs? 1. How many Cls? 1. How many fluorines? 2. Product side, how many sodiums? 1. Chlorines 2. Fluorine 1. Now what can you do? Here fluorine is 2. Here fluorine is 1. You have to make it to 2 by adding a number. Don't add 2 here at subscript. You have to place in front. If you place in front, 2 should be given to sodium, 2 should be given to fluorine. Now product side, how many sodiums? 2 it has become. How many fluorines? It has become 2. Chlorine we didn't change it, so it is 2. Here fluorines 2. Okay, fluorines got balanced. Now chlorine, sodium, what we can do? Simply we can put 2 in front of sodium chloride. Now sodium reactant side, sodium has become 2, chlorine has become 2. Now sodium balanced, chlorine balanced, fluorine balanced, everything is balanced. If you count total 6, here if you count total 6, 6 is equal to 6, satisfied law of conservation of mass. Here if you didn't find any number, you can substitute just 1. because 1 into 2 it is 2 only, count will not change. Now this fourth equation without writing reactants and products, can you crack it? How many hydrogens? 2. How many hydrogens? 2. Reactant side 2, product side 2, done. While coming to oxygens, reactant side we have 2, product side we have only 1. Substitute 2 here. If you substitute 2, 2 is given to oxygen, and this side there are 2 oxygens got balanced, but 2 is substituted, I mean given to hydrogen also. Now how many hydrogens? 2 into 2, 4. Now here it is only 2, so we have to substitute a number, result should be 2. 2 into what is equal to 4? 2. 2 into 2, 4. Here 2 into 2, 4. Oxygens 2, oxygens 2. Here you can place 1. Now it is balanced. Now can you balance remaining this? You can write this one. You can pause this video, write equations and try to balance it. I'll say this one. P plus O2 gives us to P2O5. Reactant side we have P, O. Product side also we have P, O. And how many P's reactant side? 1. How many O's? 2. How many P's product side? 2. How many oxygens? It is 5. Now, how to balance? Here if you observe, reactant side oxygens 2, product side it is 5. Both are different numbers, even and odd. So you need to multiply. Here simply what we can do, you can put 5, 5 to 10. Here you can put 2, 2 5 10. Done. Now oxygen has become 10. This side also oxygen has become 10. Now 2 is given to P2 also, right? 2 into 2, that is 4. Here we have P. What we can do? Simple. Just you can substitute 4. Now equation is balanced. If you go with this one without writing, can you do it? Na1 balance, H2 balance. Here you see guys, here we have H2, isn't it? Here we have H, isn't it? How many H here? 1. How many H here? 2. 2 plus 1, it is 3 now. Like that you have to take. Don't get confused. You have 1 hydrogen here. So it is 1. Now how many hydrogens here? It is 2. So 2 plus 1, it is 3. Total hydrogens reactant side. Reactant side 2, product side 3. So it is a little bit confusing. What you can do, you can substitute 2 here. 2. Okay, if you substitute 2 here, sodium has become 2. Here you can substitute 2. Sodium become 2. Now both are balanced. After placing 2 here, how many oxygens? 2. But hydrogens if you count, this 2 is given to hydrogen, this 2 is given to hydrogen, 2 plus 2, it is 4. Now here already there is 2. You can substitute 2 here. Now hydrogen has become 4, oxygens 2, oxygens 2. Now last this one I will say, reactant side, carbon, oxygen, here we have hydrogen, of course here we have oxygen, no need to repeat. Product side, carbon, H, hydrogen, O, oxygen. Now if you count, how many carbons reactant side? 1. Oxygens, here we have 2, here we have 1, 2 plus 1, it is 3. How many hydrogens? 2 we have here, so 2. Product side, how many carbons? 6. How many oxygens? Here we have 6, plus here we have 2. 6 plus 2, it is 8. Now, how many hydrogens? Here we have 12. Isn't it? Now try to balance. So if you balance this one, how to balance? Now don't touch this oxygens, everything. Here you see hydrogens 12. Here hydrogens 2. So how to make it 12 there? Just you can substitute 6. If you substitute 6, 6 2's 12. Hydrogens 12 now. Here already we have 12. Hydrogen is balanced. After placing 6, how many oxygens here we got? 6 is distributed to oxygen. So 6 plus how many oxygens here we have? 2. 6 plus 2, it is 8. So reactant side we have 8 oxygens. Product side, of course, we didn't change anything. 6 plus 2, that is 8. So this is also balanced. Now we are left with carbon. How many carbons here we have? 6. So what to do? Here, how many carbons here we have? 1. We don't have any other choice. We have to put 6 here. So if you put 6, it will become 6 CO2, 6 H2O. Again, what we have to do? We have to count. How many carbons? 6. How many carbons? 6. Balanced. How many oxygens? 6 should be given to oxygen. 6 twos, 12 now. Now here 6, 12 plus 6. We have 18 oxygens this side. Here we have only 8. Then what we can do? Substitute 6 here. Now try to count it. How many carbons? 6. How many carbons? 6. Balanced. How many oxygens? 6 to 12. 6 into 1, 6, 18. This side we have 6 and 6 to 12. 12 plus 6, it is 18. Balanced. Now hydrogens, we have 12 this side, we have 12 this side, balanced like that. Count the number, arrange numbers in front of the atoms. Now you can pause this video, try to balance these equations, and you can check answers later. Now I'll give answers. Before doing that, you can pause this, solve that, and check the answers. Well, coming to this FeCl3, 1 FeCl3 plus 3 NaOH gives rise to 1 FeOH taken thrice plus 3 NaCl. And if you go with this one, 2 Ag2O gives rise to 4 Ag plus 1 O2. If you check this, S8, 1 S8 plus 12 O2 gives rise to 8 SO3. These are answers. I'll give few more examples such that you can go with answers. Guys, here we have a worksheet where you can find these equations, and let us try to balance this one. You can pass the screen, you can write these equations, and then you can check answers for this. Now if you observe this first one, Fe plus Cl2 gives us to FeCl3. Reactant side we have FeCl, product side we have FeCl. Reactant side we have 1 and chlorines 2. Product side we have 1, chlorines 3. Not satisfied. Now what you can do? Here chlorine is 2, here chlorine is 3. Here what you can do? You can put 2 number, you can put 3 number here, such that there are 6 chlorines now reactant side. At product side, of course, we have 6 chlorines. But after adding 2 should be given to iron also. Now here iron, we should not substitute any number at the subscript. No, you have to place 2 in front of this one, like that. And second one, you see FeO2. How many Fe's? We have 1. How many oxygens? We have 2. Reactant side. Product side, how many irons? 2. How many oxygens? 3. Now anyhow we have 2 irons here. You can substitute 2 first. Let us see 2. Now iron has become balanced. 2 iron, 2 iron. Okay, but oxygen is not balanced. Here it is 2 and here we have 3. So we don't have any option. We have to put 2 here, 3 here. Now if you put 3 here, 3 into 2, that is 6. And here if you put 2 into 3, that is 6. But problem is with iron. How many irons it has become now? 2 into 2, it is 4. So it is 4 now, like that. Now you can go with this just by looking. You can say irons 1, irons 2. First substitute 2, let us see. If you substitute 2, iron 2, iron 2 balanced, Br bromine 2 into 3 6, and here bromine we don't have anything, so try to substitute 6. Now bromine 6. After substituting bromine 6, hydrogen has become 6. Now if you observe hydrogen, it is 2, substitute 3 here. Now hydrogen 6. So iron balanced, bromine balanced, hydrogen balanced. Here if you observe, SO4 taken thrice. So this 3 should be given to SO4, right? Anyhow, we have placed 3 here, isn't it? So this 3 is given for SO4 only. Now here 1. So answer is 2 FeBr3 plus 3 H2SO4 gives rise to Fe2SO4 taken thrice plus 6 HBr. And you see this D, how many carbons? 4, hydrogens 6, oxygens 3 plus H2O means hydrogens here also it is there, we have to count. 6 plus 2 it is 8, 3 plus 1 it is 4, reactant side. Product side C2 H4 O2. Simply to say 2 is half of 4, 4 is half of 8, 2 is half of 4. Just to substitute 2, now carbons 4, hydrogens 4 2 is 8, oxygens 2 2 is 4. Here also same thing. So 1 1. Now this 2 carbons, 1 carbon. Place 2. Now if you place 2, how many oxygens? 2 into 2 4 plus 1 5. Here it is 2. So how many hydrogens here? 4, right? Here reactant side 4. Here we have 2. What you can do? You can substitute 2. Now hydrogen got balanced. Hydrogen got balanced. Carbons 2. Carbons 2 done. Oxygens how many? 2 into 2 it is 4 plus 2 6. Now if you substitute 3 here, 3 into 2 it is 6. Now F you can balance. What you can get? C4 only C. So substitute 4. Carbons 4 now. Now hydrogens how many we have? 10. How many hydrogens here we have? 2. So you can substitute 5. 5 to 10 now. Now if you calculate number of oxygen atoms, reactant and product, reactant side we have 1 plus 2, that is 3. And here if you see 2 we have, 4 we have, 4 into 2 8 plus 5 into 1 it is 5. Little bit confusing for us. So what we can do? Here you can substitute 6, let us see. 6 to 12. 12 plus, here we have 1, 13. 8 plus 5 it is 13. Like that you can balance. Now you can balance remaining this one. You can pass, balance, come back, check the answers. For G it is 1 11 O2 7 CO2 8 H2O. H 4 H2 SiCl2 plus 4 H2O gives rise to 1 H8 Si4 O4 plus 8 HCl. This 10 HSiCl3 plus 15 H2O plus 1 H10 Si10 O15 plus 30 HCl. Guys, this equation is time taking equation. It will be going on because you will go with first 3. If you don't have, if you will go with 2, if you don't have 2, you will go with 3 and then 4 and then 5. You will be going on. So it might be difficult. J 1 3 1 3. Last 1 C5H8O2 plus 2 NaH plus 2 HCl plus 1 C5H12O2 plus 2 NaCl. So by this we have seen how to count atoms, and we have seen how to balance chemical equations. That's it in this lecture.